Hello, my name is Johnny Ryan, and I am an assistant professor in the Department of Geography at the University of Oregon. And joining me here today is Patrick Bartlein, otherwise known as Bart. He is a professor also at the Department of Geography in the University of Oregon. Bart completed his undergraduate, master's, and PhD at the University of Wisconsin in the Department of Geography between 1968 and 1978. After a one-year postdoc at the same institution, he moved to Boston University as an assistant professor, where he spent 3 years before moving to the Department of Geography at the University of Oregon in 1982. Bart, thank you very much for joining me today.
Sure.
So I'm going to start from the very, early stages of your career. But when you can kind of think back and take yourself back to the Midwest, what was it? Was there a specific moment that you became interested in geography, or was it more gradual?
I don't think I ever was not a geographer. Grew up in Wisconsin. Later on, it emerged that we were living on a recessional moraine of the Lake Michigan lobe. For as long as I can remember, I knew about how there used to be a mile of ice where Lake Michigan is now. And my father was from Milwaukee, my mother from Rhinelander, the northern part of the state. That's up on the Canadian Shield, where the glaciers scraped everything down to bedrock and piled it up into southeastern Wisconsin. And in taking family trips, it was easy to see that there was something really different about northern Wisconsin than the rest. And my dad knew about that and explained what was going on. So I think like from day one, I kind of knew about quaternary glaciation, not really appreciating its significance. So I was kind of still amazed to realize that what I'm doing now is something I've been doing since I've been 5 or 6 years old. In Wisconsin, you just kind of know about these things. Then later on, I got interested in meteorology, mainly from the severe weather aspects of it, which is something else that goes on in Wisconsin. And then eventually figured out I wanted to be a meteorologist. There was a good place to do that in Wisconsin at the University of Wisconsin-Madison. But then, owing to the way things worked back in the fall of 1968, it turned out that you had to make 1/8 of the progress towards a degree program every semester, or you'd become eligible for the draft. When I was registering for courses, they said, okay, well, meteorology, you're going to be taking chemistry, physics, calculus, but you should take something else that's just for fun. And I looked through the catalog, discovered Geography 101, Physical Geography, which was sort of the junior intro course, signed up for that. The advisor said, well, that was a big mistake because it had a lot of climate in it, but it also had landforms, vegetation, and so on and so forth. So I signed up for it. Then in my sophomore year, it turned out that I couldn't get into the right math class, but I realized I could switch majors and still be on track to not getting drafted, and switched to geography. And I signed up for Don Curry's geomorphology course. Curry was a pretty amazing guy, kind of the typical absent-minded professor. He'd come in before class, fill the board up with notes, then leave, come back 10 minutes later, look at the board, kind of puzzled about what that stuff was there, erase it, and then go on to something completely different. And I thought at the time, hey, I think this is okay. It turned out the teaching assistant in that class was Will Graff, who at just the right time told me, hey, I can get this stuff. And so, you ought to stay in this major. I also took human geography courses then called cultural and cartography. And then my junior year, I was talking to Will, and he said, maybe it's time for you to take some independent study courses. How about you should check out Jim Knox and talk to him? And so I did. And that's what got me, kind of fully invested in geography. Then when it came time for grad school, I applied to the QRC in Seattle, but there was a lot of stuff in Madison to hang around for. Of course, meteorology, geology, there's a soils department, there's a department of hydrology. Madison had a statistics department, which is pretty unusual. And so there was this spirit of sort of interdisciplinary collaboration there, which meant that you could pretty much talk yourself into any class, sitting in on it, just by showing up and saying, hey, I'm interested in your class, and it's okay. So I was able to take time series from George Box, the guy that said all models are wrong, but some are useful. He's famous for that. Took lots of courses in atmospheric sciences, particularly from John Kutzbach, who later on I wound up actually collaborating with, and then essentially kept doing kind of the same things I've been doing all along. Then a key thing happened when we moved to BU. We went to the American Quaternary Association meeting in Maine, and I ran into Tom Webb, who was a PhD student in meteorology at Wisconsin, about 5 or 6 years ahead of me, and he was then at Brown. And I introduced myself, told him what I was doing. At that point, it was statistics with atmospheric circulation and streamflow, and noted it was a lot similar to what he was doing using fossil pollen data to reconstruct past climate variations. And so he invited me down to give a talk. We started collaborating, and still are. We worked on a paper last summer, and so that's quite some years. Then at BU, since the commute to Brown was pretty easy, we collaborated a lot more, and that eventually got me into an interdisciplinary research group that Tom was running, along with John Kutzbach at Madison, Herb Wright at Cushing, Minnesota, and Elaine Street Parrott at Oxford then, called COMAP, which eventually got the name Cooperative Policy Mapping Project. And the basic idea was to use climate models to look at the mechanisms of past climate change, and paleoclimate data to, in a sense, test the models. The data record what happened, but don't really explain it. The models could do that mechanistically if you know they're right, and so it's a natural interplay between the two, and that's gone on since the late '80s, and we're in probably the 6th iteration of it. It's the 4th formally organized one called PMIP, or Paleoclimate Modeling and Comparison Project, and there seems to be no end to what you can do and what you can figure out about both how climate models work and what they explain about past climate variations. So in a sense, like I said, I'm still doing the same stuff I was kind of interested in when I was 5. Which I don't know.
You can definitely tell that from your CV that you've had quite a linear trajectory.
Yeah.
So, you've talked about your time at Boston University, and you arrived in Eugene in 1982 in September.
Right.
Can you think back to that time when you first arrived, and can you think about some of the differences between the Department of Geography at the University of Oregon with your previous institutions? Well,
I came here as a trailing spouse with Pat McDowell. I had some soft money and was able to kind of make that work. The departments, were on paper were a lot different, but in a sense not really, because they were all full of geographers, and so my definition of a geographer has always been somebody that cannot not look at a map, and so you can that kind of unifies us all. Madison had a vast map library that you could wander around in. BU was a lot more, not flush with lots of library resources in geography, but it was in Boston, so there was Harvard and MIT across the river. When we got to Oregon, I was glad to see that there was a map library again, and the utility of just being able to go and grab an atlas to look at, say, the vegetation of Baffin Island, any time you needed to do that was pretty useful. In terms of the traditional splits of geography, Madison was pretty standard in the 3 subdisciplines. B was a little bit more organized towards economic geography, and then later on in GIS. And Oregon at the time was still kind of laboring under the Berkeley North idea that it was just a kind of a replication of that department, but it really wasn't. But nevertheless, that was that was kind of the notion at the time.
That's awesome. Yeah. So, come this September, you will be a faculty member at this department for 40 years. And some things, well, many things have changed. Some things haven't. We're still in Condon Hall, for example.
Yep.
But did you ever think you'd stay in University of Oregon for this length of time?
Well, at first, not really, but it didn't take too long to discover that this was a supportive place for doing the kinds of things I wanted to do. Of course, one of the things was that I was collaborating with people all over the place, and in Europe and other places in the U.S. And so we were really early adopters of networking and and things like that. So when we moved here, actually had some $600 of startup money to buy a televideo terminal and a acoustic modem to be able to connect to the computers back at Brown. And then that gradually graduated to a Gandalf switch, was like a phone line, then BitNet, and then finally, finally the internet. We also do something that, again, I'm strangely doing, which is to mail data around on, first it was on boxes of floppies, then 3-1/4 discs, then Bernoulli boxes, and I'm still doing that, where it's a lot easier and faster to put many terabytes of data on a bare hard drive and FedEx it to somebody than it is to download it over the network.
Yeah.
So it's the ability to be able to do that really kind of opened things up, and made me realize there's kind of two things that sort of support work on a day-to-day basis. One is where you are and whether it's a stressful situation or non-stressful, and U of O is definitely non-stressful. And the other thing is the collaborators you've got, which can be both in the department and anywhere in the world. So the trick is to be able to find that kind of arrangement.
Yeah. Well, on the similar kind of theme, then, so your research is using a lot of kind of models and can be quite data intensive. How would you say that technology has shaped your research?
In a strange way, what's changed the most is just the scope of what we're doing rather than the actual process. Mm-hmm. So I did my dissertation on using a set of gridded atmospheric circulation data and streamflow data from around the country, and had to keep paring the data set down to the extent I could finally do a principal components analysis on the circulation data, which at the time required getting a note from the dean that said I was allowed to use all of the 1108 UNIVAC computer at one time in Madison for this particular analysis. And I'm still doing that, but now it's on data sets that instead of 20 years of monthly data, it could be 22,000 years of monthly data, a lot more grid points, and I'm doing it on a desktop in R. So the process is the same, but there's been a huge democratization in what you can actually do now on desktop computers and things that are kind of manageable and get the results you need when you need them.
So obviously a large part of your job is teaching, and you've spent, you've taught many classes over the last, time that you've been in Oregon. What do you think is unique about the education that the students receive in the Department of Geography compared to maybe the pure sciences or the pure social sciences?
Well, they do make contact with other parts of geography, and that's particularly noticeable. I've got an extra exercise in climatology where I use the Yale climate opinion maps that were put together by Jen Marlin, one of my PhD students, and Tony Lazurowitz, who runs the Yale Climate Communications program. And these are maps that just basically show the distribution of the percentage of people that think climate change is real, that it's going to be a problem, and so on and so forth. And of course, the interesting thing is you see those demographic differences that you see in the vaccination maps and other things like the presidential elections. And the questions I asked students about the maps are, can they figure out what the patterns are from? And it turns out they can, and it's not from anything I told them, and it's things from coming in from other courses in geography and elsewhere. But you get a strong sense that, one way or another, we're turning out people that really do have a broad enough background to take the notion of, where things are and why they're there, and apply it to something that they hadn't actually seen before, or been asked to look at. So I think that's something that's actually maybe inherited from the old Berkeley North idea, where we heard stories about how when in the 70s and 80s, or 70s and earlier, everybody had to teach something of everything, and so you'd find people that mainly taught physical having to also teach a historical geography course or something like that. That's horribly inefficient now, but it does get at this idea that what's kind of important is the geographicalness of it rather than a specific specialization. That also is what one of the things that really kind of sort of helped out in doing this interdisciplinary climate change research, because it kind of leads to a situation where you feel at ease in asking stupid questions. So no climate modeler could fully understand what's involved in turning mud into reconstructions of biomass burning or vegetation. In the same way, paleoclimatologists sometimes are kind of, in awe of the physics speak underneath modeling, calling things boundary conditions instead of inputs and things like that. So I was in a good position to ask stupid questions when they needed being asked. And I've always told my students that too, don't be afraid about asking stupid questions. Yeah. There are really stupid questions, but normal stupid questions are just fine, because if you don't understand it, chances are somebody else doesn't either. Mm-hmm. And that's how you make progress.
Yeah. So on the subject of kind of climate change, you've been studying this, your PhD thesis was titled, the influence of short period climatic variations on stream flow in the United States and southern Canada. If you think back to then and then again forward to now, have your concerns about climate change evolved during your career?
Well, sure, yeah. I think I gave my first kind of professional talk on global warming and future climate change, like maybe 1979, and I came across those transparencies a few years ago, and I could use them today,
Yeah.
And so the same issues there. Things that have come more into focus is just the size of the impact and all of the environmental systems that are going to be involved. Nothing's going to escape. So that's that's certainly evolved. It can be a very kind of depressing subject to teach. It's students pick up on that. It's kind of hard to keep them really relaxed, particularly when you teach a course like climate change or global environmental change, which could have a subtitle, things are bad and they're going to get worse. So one of the things I try to emphasize is that, hey, all's not lost. We still have a lot of big levers we can pull to nudge things along in the right direction. And we can see this happening. Even 4 years ago, would anybody have expected that Ford would be selling electric pickup trucks in 4 years' time? So we're not by any means even close to coming up with a fix for climate change, but we're heading in the right direction. Mm-hmm. And by fix, I don't want to imply geoengineering, because that's a crazy idea.
Mm-hmm. Okay, slightly pivoting again. You were on sabbatical in 2002, and in the department newsletter, your faculty update claimed that few other things represent the embodiment of places' physical, cultural environment than a bottle of wine.
Yeah.
Has your interest in wine enhanced your research? If so, how?
Well, I don't know who talked me into that, I guess. But yeah, when you get right down to it, wine is you can't really think of a better integrator of environment and culture. And so, I'm still interested in it. One of the things that's kind of enhanced that is some of the early meetings on looking at the global record of biomass burning over the last 20,000 years happened to be run in the Rhone Valley. And so it was kind of a natural thing to go on a little field trip. And similarly, PMIP has always been mainly managed through the French Laboratory for Study of Climate and the Environment. And so meetings there also kind of featured wine. Most recent meeting was in Bordeaux and had a prehistoric wine cave on the hotel grounds, and so that kind of invites exploration. So, but I haven't really done anything professionally. But maybe in retirement. Yeah.
That's good. So, obviously, it's well known. You are married to Pat McDowell,
Yep.
Another faculty member here in the department. But I was quite surprised to find that you've only actually co-authored one publication and only 2 book chapters together, which is kind of surprising for me. How else have you supported each other's careers?
Every way. So it's as you know, it's kind of incredible to be able to kind of talk about stuff that you're interested in and excited in. Without fear of being boring or, take a conversation in a way that's not, very exciting. So I think that's that's the main way. The other thing that, of course, is since Pat is really interested in the landscape around us, it's hard not to be able to kind of profit from that and just to help my own interests and seeing what's going on around us. So plus we're on the same schedule, so that's always a help as well. And of course, she's had some nice meetings to go to.
That's good. Yeah. So, okay, let's maybe think a bit more like towards the future now. You're beginning to retire. What do you think the department's greatest challenge is in the future?
Well, a couple. One is staying current with the changes in the discipline, and that's where the chances we have to kind of do that is when there are new hires and things like that. We also have to continuously tell other people, administration, our colleagues in other departments, what we do, because one thing that always happens is that other people invent geography, over and over and in a fairly routine fashion. And so, like every 3 years, somebody comes up with the idea, like, hey, we should teach something on, maybe climate change, and so we have to be, continually diligent to advertise what we do and tell people, yeah, we're doing that. So that's a continual challenge, and it's also something that administrators have to be reminded about continuously about what we actually do. Mm-hmm. As for the discipline itself, I think the same thing goes there. In a way, it needs to be AAG. I think needs to be more AGU-like, and that there's probably something at AGU meetings now, which are huge relative to geography meetings, that would interest just about everybody in the department. And so, instead of focusing on a relatively small discipline, which this department has contributed a lot to, it's also good to be aware of what's going on in the wider geographical with a small g world, and in particular developments in Earth system science that again intersect with just every part of geography as a formal discipline.
Cool. So when you look at your CV and your record, it's clear that you've achieved a lot of awards. You've got an amazing publishing record, over 200 peer-reviewed papers I counted this morning, and and multiple papers in science, nature, everything. But what have you found in particular most rewarding about your career?
Well, it's collaborating with people,
Yeah.
and that's one of the reasons for a big publication record. It's not like physics, where it's all papers that start with co-authors that start with Aaron Aardvark and go to Zoe Zydeco, but collaboration does increase the impact of what you do, but that's also the most rewarding part of it, because the thing that's really great is when as you're collaborating with people, you get to talk about and think about things that you could never really do on your own. And that gets back to the asking stupid questions. It's useful if people can be relaxed enough to do that, because the way we're trained, you go through primary school, high school, you try to get in a good college, then you try to get in a good grad school by becoming more and more specialized and more the smartest person on an increasingly narrow, topic. Then you get a entry-level academic job, and then you certainly have to do that specialization. So it's maybe 12, 15 years after PhD where you can finally start branching out. But you don't have to wait till then if you're collaborating with other people in other subdisciplines or even other disciplines.
Cool. Well, I think our time is coming to an end now, so I'd like to, on behalf of the department, thank you very much for spending some time with me, and this is great.
Yep. Thanks.
Cheers.
Good job.